Let's start off with this problem here. We got 23 milligrams. We want to change it to decagrams. We're going to do it using two methods, dimensional analysis and ratio analysis. What do we do first? Let's see, where are we going? We're going from here to here. First step would be what? From milligrams to centigrams? So milligrams has to be here, centigrams has to be here. We could have our 1/10 ratio here, which tells us 10 of these is one of these. 1 goes here, 10 goes here. Now what do we do?
Cross off. Cross off.
Yeah, cancel the units. Centigrams here, because we're going up the next level. Decigrams here. We'll slide up to 1/10 ratio. Saying one of these is 10 of these. Now what happens?
Cross off.
Centigrams cancels. Slide up our ratio. One of these is 10 of these.
Cancel out the
Yeah, cancel out the decagrams, decigrams. Grams goes here. Decagrams goes there. Let me slide up my ratio one more time. One of these is 10 of these. This cancels, and we're going to get what? Let's see. 10 times 10 times 10 times 10, which is 10 to the 4th decagrams. This equals all we had to do was move the decimal 4 places to the left. Does that make sense? Does the number make sense? Well, if we're going up the scale, remember when we had the pyramid, the number's got to get smaller. This did get smaller. For every step we did a factor of 10, so there's 1, 2, 3, 4 steps. 1, 2, 3, 4 steps. Answer looks correct. How would we do it using ratio analysis? Yes. What's that? No, it wouldn't make it negative. All the terms that we have here are positive, so it has to be positive. Ratio analysis. We're going to start putting this in the numerator. It's X DAG over 23 milligrams. Okay. Now in a ratio, the units here have to be the same as the units here. The units here have to be the same as the units here. So we're going to have DAG here and MG here. So we have milligrams, milligrams, decagrams, and decagrams. Which of these two units is larger? Decagrams, right? Let's call that 1. How many milligrams are in a decagram? Well, 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. So 1 decagram is 10,000 milligrams. Now, as a shortcut to this, all we have to do is to solve for x here, is take this quantity and move it up here. So this is going to go to x decagrams is equal to 23 milligrams times 1 decagram divided by 10,000 milligrams. What's going to cancel? We got milligrams here, that cancels. This is 23 divided by 10,000, which isn't that the same thing? This is going to equal 0.0023 decagrams. There's your final answer. So we did the first time we solved it with dimensional analysis, the second time we solved it with ratio analysis. Any preference on either method?
Not yet.
Not yet? Okay.
Not yet. I say yes. Dimensional.
You still like dimensional? Dimensional analysis is a more powerful tool. But I think the advantage sometimes to ratio analysis is there's less steps involved. It is more confusing, you're right. All right, let's try another one. We have another level down here called a micro. It's 3 levels below, although they don't have the other 2 in here. So what they're saying is 1 milligram is equal to 1,000 micrograms. So there's technically 2 other levels down here. Okay. So in this one here, we're going to convert 0.6 milligrams to make that equal to a microgram. So if we're going to do this using dimensional analysis, we're over here at 0.6 milligrams times, on this here, we're going from here to here. And this, even though we only have a prefix for here and here, this is actually 3 steps. Okay? It's 1,000, not 10,000. 1,000. It's 10 times 10 times 10. So over here, we're going to put milligrams here and micrograms here. See this conversion here, 1 milligram equals 1,000 micrograms? That's this relationship. So let's say I'm going to put 1 here and 1,000 here. I can't go down step by step because they don't have a prefix for these 2 levels. So we're going to take it in one large step. Milligrams cancels. This is going to equal 0.6 times 1,000. And this is just over 1, so that doesn't matter. When we multiply this out, we're going to get what? There's our final answer, because it's 0.6 times 1,000. In this case, we move the decimal 3 places to the right, we're going to get 600. Everybody follow me on that one? That was a little different. We didn't go step by step, we jumped steps up with this one. Let's go to ratio now. Technically, we're going from here to here. There's 2 levels in here, but they're not defined, so we're jumping 3 steps instead of 1 step. That's why I came up with this 1 milligram is 1,000 micrograms. Saying one of these is 1,000 of these.
So whenever you have really learned to make it.
I'll tell you what, that's a good idea.
Well, no, I didn't want to do it.
I know you didn't want to do it, but now I want to do it. Let's do this with ratio analysis, and then we'll do that one. We'll see what it's like. Maybe that'll foster a little more understanding. All right, this is going to be X. We'll do this over here. All right, this is going to be X microgram. With ratio analysis, we start with our unknown in the numerator. Here's our conversion. We're converting this to this. So the known quantity is in our denominator. The unknown quantity will go in our numerator. Now, we want this unit. We want milligrams to be in both denominators, so I'll start out like this. I want micrograms to be in my numerator, so I'm going to put micrograms here. Now, I gotta look over here, which one's larger, which one's smaller?
Milligram.
Milligram.
Milligrams is larger, right?
Yes.
Going up.
Well,
Maybe going up.
milligrams is here, micrograms is gonna be here. So this one's the larger unit. So I'm gonna put 1 here. Now I'm gonna ask myself the question, how many micrograms are in a milligram?
1,000.
1,000. So I'll put 1,000 over here. Because this is saying there's 1,000 of these in one of these. Now technically, we can pick any numbers we want as long as this relationship is the same. I could have said this is 5 and this is 5,000. That would elevate the numbers and make it a little harder. I like 1 because it keeps the number small, it's easier to calculate. But any value, as long as the relationship between these two numbers is the same, will work. Okay. Now, all we really have to do is bring this quantity up to here, right? And that will solve for this. Or you can use your cross product, but that's 2 steps. This is just 1 step. I think it's a little quicker, a little easier. So this goes to X mcg is equal to 0.6 milligrams times 1,000 micrograms divided by 1 milligram. That's what we end up with, right? After we do this manipulation. Now, we have milligrams in our numerator, milligrams in our denominator. We can cancel those out. Dividing by 1 really doesn't do anything, so the only computation we have to do is 0.6 times 1,000, and that's going to give us 600 micrograms. There's our final answer. All right, so we used 2 different methods of solving for this. Did we get the same answer both times?
Yeah.
So it works out. A moment ago, Paula had a good problem. Let's figure that
I
one
didn't
out.
want to do it, so.
I know you didn't want to do it. You don't want to do anything. This may be a good learning activity. Has everybody got this down? Everybody good? All right. Paula, what did you want to do? You wanted to use dimensional analysis and you wanted to go from grams to micrograms. All right, so let's pick up a number. I'm going to say 5 grams. We're going to go to some number of micrograms. So we'll start out with 5 grams here, times. We got to go down to this level, right? So we'll move our 1/10 ratio. Grams goes here, what goes here? Decigrams? 10 of these is 1 of these. Grams cancel. Over here, we want to have decigrams. The next level down is what? Centigrams. This ratio moves down 1 level. So 1 of these is 10 of these. Decigrams cancels. We have to have centigrams in our denominator, milligrams in our numerator. Slide down our ratio again. One of these is 10 of these. That cancels. Now here's the tricky part. Now we're going from here to here. We're jumping 1,000, right? So 1 of these is, how many of these? 1,000. Milligrams cancels. This is going to equal 5 times 10 times 10 times 10 times 1,000 over 1, and this is going to be micrograms. So this is going to be, this is going to equal 5. So 5 grams is 5 million micrograms. But this here, ratio here, represents that giant step. It's like we're walking downstairs and then we're going to miss 3 steps and go down to the next level. Some of you may have done that, on the staircase once in a while.